So finally, we get to the last topic of this unit, and that's tracing. And what is tracing? Well, it's whenever you go through your program line by line and record everything that happens. And it's used to verify, number one, that your program is correct or your algorithm is correct. And it's also very useful for finding bugs and errors in a program. Okay, so how do we trace a program? Well, so say we have a program that has a bunch of lines in it, and it's going to ask you for your first name and your last name, and then it combines them together and prints something out. Well, first, what you do is you build a chart that looks like this, where you have your line numbers and an input column. Then you have a column for each variable that you may have used during that section of the code. And then finally, you have a column labeled output if your program outputs something. So we go through our program and we get to the point of the code where it's going to prompt you to input your name. In this case, I put in Corey. So we have our input, and then we store that input into the X variable. And then on line 3, we do the same thing, and it says, okay, please input your last name. And then so we're going to store my last name in the Y variable. And then we're going to do some work with it, and maybe one of the steps in there somewhere is it combines the two names and stores them in the Z variable. And then finally, later in the program, it's going to capitalize everything and output hi, first name, last name. Okay, so this is how you would use the program trace to go through. Now, some points on this is if you loop, you just repeat the line numbers. So you don't pre-fill the line numbers, you enter the line numbers as you execute them in your as you would execute them in the code. So you go through line by line, and you don't actually run the program. You chart this out, and you execute the program like you would if the computer was actually doing it. So you say line 1, okay, it does nothing. Line 2, asks the user for their name and stores it in X. Line 3, and then if it loops, you would go line 2, line 3, line 2, line 3, line 2, line 3, and those would keep repeating in the rows of the table. And so this is how you would use program tracing to go through your program step by step and see what is actually going on. And it's useful to find bugs, especially early in your programming days. I mean, you're going to do tracing and debugging all the time, but you're going to get a lot better at it as you progress in your education and experience. And you won't necessarily have to draw out a chart like this. But for now, you're going to draw out a chart and make sure that if you have to do this for your homework, that your variables and your outputs are 100% accurate for full credit. I will say this one thing is I think the input is a little redundant. Some places have you do it. Some things say you don't need to. The book it actually shows it without doing an input. So I'm indifferent one way or the other. If you'd like having the input column there, you can do it. If you just want to have the line numbers and your variables and your outputs, that's fine as well. So to recap, let's take a look at all the pseudocode stuff that we've learned already. First, print statements. You're going to print strings, variables, math expressions. You just type, write the word print and then whatever it is that you want to print. If you're going to be printing out a string literal, you're going to surround it with quotes. Same thing with input, very similar to print. It's just input and then whatever variable it is that you're going to store the input into. So if you're asking for a first name, you would put input and then name. Variables, make sure they have no spaces and they're all lowercase except for each second, third, fourth words. We call that camel casing. So if you create a variable named first name, then at first is all going to be lowercase, and then name is going to be capitalized, but there's going to be no spaces. Assignment statements, we have the value and then a left arrow going into the variable that it's stored in. So I kind of read that backwards, but that's how you read it. And that's because in code we do it the same way. We have the variable, except for instead of an arrow, we use the equal sign and then the value. Math operators, you should be familiar with those, and then also add in that the modulus operator, which is the percent sign. And then finally, we also covered if conditions, else if conditions, else, whiles, and we'll get into do whiles in the next chapter, but it's another loop as well. So that's a good recap of everything we covered. We also covered flowcharts, we covered pseudocode, we covered loops, nested loops, a lot of stuff that's going to be really useful as we progress on into the semester. So that's all for this video. It's going to be very short. I would encourage you to get started on your homework, and that's it.